This Industry 4.0 refers to a specific concept, basically. It means manufacturing where machines have additional capability of wired or wireless connectivity with sensors, and these are connected to a system which is capable to visualize the entire process, production line, and make the decisions. Industry 4.0 also describes the use of automation and data exchanges in manufacturing technologies and processes. They include cyber physical systems, CPS, Internet of Things, IoT, Industrial Internet of Things, IIoT, cloud computing, artificial intelligence. In short, we can say it encourages the development of a smart factory. Let us have a look at the industrial revolutions first. Let us go to first revolution. It is 1760 to 1840. This was a transition from hand production to machines, and this was possible through the use of steam power and water power. The implementation of new technologies took a long time. So the period is from 1760 to 1840. In Europe and USA, it affected and had consequences in textile manufacturing, which was first to adopt such changes, and then it was used in iron industry, agriculture, and mining. Then came the second revolution, that is Industry 2.0. This was the period between 1870 and 1914. This revolution was made possible with the extensive railroads, telegraph lines, which made possible for people to travel fast, and also ideas could travel fast. It was also marked by the use of electricity, which were used for factory electrification and the modern production line. It was also a period of big economic growth and an increase in productivity. This caused a surge in unemployment because there was a lot of automation. The picture which I am showing you now is a Ford assembly line. It was a very new concept at that time. It was, you may say, a sort of a beginning of automation. Then we go to the third revolution. This occurred in the late 20th century. And this was a result of the industrialization and technological advancement. This was much lesser in previous periods. It is also called digital revolution. The global crisis in 1929 or 1930 had some negative setback, but it again picked up. The production of electricity driven mechanical calculator was the beginning of new calculator. Then we had progress in the development of communication technologies, computers, supercomputers, extensive use of computer, communication technologies, and machines started to reduce the need for human power. And this ushered the new area of automation. Then we talk about the latest, that is Industry 4.0. And my question is, are we ready? That is the question everybody may have in his mind. So for example, progress is made very fast. Just to give an example, 20 years ago, these things did not exist. For example, Android, iPhone, iPad, Kindle, Instagram, and the time to reach 100 million users took very short time. For example, telephone took about 75 years, net services took 7 years, Facebook 4 years, Instagram 2 years, Twitter 2 years, and now Pokemon only 19 days. So progress is made very fast, and it will happen in future also. Where we are. So we are much lower in the ranking. We are only at about 91 globally. Even countries like Malaysia and Korea are above us. But I think we will rise very fast, and we can be very sure about that. How does the term come? The term Industry 4.0 originated in 1211. There was a project in the higher tech strategy of the German government. The Industry 4.0 was publicly introduced in the same year at the Hanover Fair. And then in October 2012, a working group was formed, and they presented a set of Industry 4.0 implementation recommendation to the German government. And in 2013, at the Hanover Fair, the final report of the working group Industry 4.0 was presented. This was the beginning. We talk a lot about smart city, and we have been talking about it since long. For last 10 years, 5 years, there was a lot of discussion in the political newspapers and all avenues. What is that? People at large have a very vague idea actually. Actually, a smart city uses Internet of Things sensors to collect the data. Data includes information from citizens, devices, and assets. The data is processed into a central system, analyzed to monitor and manage many city utilities like traffic, transportation systems, power plants, water supply networks, waste management, crime detection, schools, libraries, hospitals, and many more. So ideally, a smart city is supposed to do all this. This uses information and communication technology, that is ICT, and various physical networking technologies. Frankly, we do not have any smart city in India as on today, or even a small cluster in India today. We are a long way to go in this way. So let us restrict to our factories only. What is a smart factory? Before that, Industry 4.0 consists of many components. To understand how extensive these are, I'll just read them. Advanced Human Machine Interface, that is HMI. In 3D printing, most of the foundries are already conversant with this. Smart sensors. Smart sensors means sensor which can transfer the data directly. They don't need any intermediate junction box, intermediate boxes. Straight it can go to the destination. The Internet of Things platforms, location detection technologies like our mobile phone detects where we are. These are detection technologies. Then big data analytics and advanced algorithm. This is a simple but very complex word, but simply I would say if you want to buy something on Amazon, Amazon tracks you continuously and finds what you like, what you don't like, what you're looking for, products and everything, and what sites you visit, what sites you don't visit, how much time you spend on the sites, and all that data is clubbed together to find out exactly how they can market your product. So this is a data analytics science. It is itself a different branch of science. Let us not get involved in all this complexity. Let us proceed further. Before I give an example, for example, today, the cars are manufactured on the production line in a rigid sequence. But tomorrow's factory will have assembly lines, fully flexible, highly integrated. So the assembly line will change based on the needs of the customer, color of which he likes, or additional accessory facilities. A few cars will be manufactured that way. Some other cars will be manufactured with different colors. For example, in medical manufacturing, artificial knee and hip joints are made as a standard product, and they can be made very fast. And today, this is what is happening. And if you want to have something different for your knee, for example, it will take a couple of days to do that. But today, new software and steering solutions make possible to produce an implant in 3 or 4 hours. For example, it is very easy to go to a dentist and get a new denture without leaving his clinic in next half an hour because this new technology. I'm giving an example of a foundry because most of us are foundrymen here. I'm giving an example of a ore making machines, for example. When the sand drops below the reorder level, the system places order for the next supply. This is a simple way of working, but the system is reactive, not proactive. So next smart level will be to have a system tied into the production control system within the foundry. It will use the data from material consumptions, order lines, then it will predict the data for sand, chemicals, consumables, everything. And for the coming week or the months, it will send the data to the concerned departments to order, to store properly. This is a typical foundry application when you say my foundry is a smart foundry. How do we know whether we are ready? So I am giving an example of VDMA. This is the German Engineering Federation. This is a 6-dimensional model which is developed by them. This model is universally applicable. It is applicable to India also. And this model will help us to assess our readiness and various critical parameters. It will also analyze the gaps which will have to address to adopt the Industry 4.0. What is that? Let us go one by one. First is the current openness and the cultural interaction can be examined by the first step. The existing knowledge strategy implementation of Industry 4.0. Second point, review strategies through a system of indicators for better operation. Each point can have a little discussion. They measure the enterprise investments, economic investments related to this Industry 4.0. Understand the use of technology and innovation management, and also understand the current state of your R&D department. You may feel that the industry, our own industry, we know very well. It is not so, because this model may open your eyes very widely. A few things will come out when this model is adopted or checked against your industry parameters. Then, what is my progress in my company in the area of smart factory? We can measure it by digital modeling, how much digital signaling we are using, in equipment and modeling infrastructure. I talk about that again. How much data we are using in my company, what are my IT systems, and what is the infrastructure for that. Basically, this point means how well your company is conversant with IT technology. Most of the foundries in India are yet to adopt to this IT technology fully, but when they do that, they can say that we are nearer to a smart factory. Then what are my smart operations? How much am I ready? How much information I'm sharing with human beings as well as between machines? Cloud usage. Cloud is a technology used for software. How much usage I'm doing of that cloud, because cloud is a big data hub where I can store my large data, which is very safe. What is my IT security? It is very important. And what are my autonomous processes which can work automatically without any human interference? Please appreciate that all emphasis here is on cloud technology. It is very important. Further, how smart are my products? So we can check the readiness by looking at the information and communication technology, that is ICT, on add-on functionalities of products. What are add-on functionalities? I'll explain in a moment. See the extent to which data from the usage is analyzed. Are my physical components are equipped with technical components such as sensors, radio frequency identification? I've shown a tag here. Everybody knows this tag. This tag is always available on our packages, which senses or gives the data of the product. And this is also put on some casting. You can see the casting here. It has got a tag which can transfer the data from the casting electronically to a machine or a data center. So most products we buy now have got this RFID or the barcode data, and the castings also can speak to each other or to the machines. And this can also be used for traceability purpose, because in automobiles, the traceability is a very vital function. So this is a very important factor if you want to trace your products. So smartness for the products is necessary. Now let us check the readiness for data-driven services. Availability of services. For example, the physical products themselves must be equipped with physical information technology, so they can send, receive, or process information needed for their application. With a SandCore machine, it should have facility to receive the data from the central station to operate. You have a molding line, it should have a data center, port to get the data. It should also be possible to send the data from there to basic control center. Similarly, for after-sales services, if you are supplying a machine or a casting, then the evaluation of the customer's data, evaluation of the performance of the machine or the pump or the whatever you are supplying, the analysis of the data should be possible from the product. And then you can definitely evaluate the share of revenue derived and share of data used. So when you do all this, then you can say, yes, my services are data driven. I'll give another example. A die casting machine has a port. We can send the data to the manufacturer so he can monitor the machine in case of any breakdown or can offer services without sending a service engineer. Or you have spectrometers on the in the factory which are a bit away from the shop floor. So the spectrometers can send the data to the shop floor electronically on the display. And even today, the sample is sent by sample chute to the spectrometer. So you can get the analysis on the shop floor within a few seconds or few minutes as soon as the sample is burnt. So that is I say, data-driven device. And the spectrometer also a facility of telling the operator what additions have to be done based on the data he may already have, what product he's supposed to make. So all this is possible. So many equipments have these ports. If they don't have, you can look for them. The crucial part is employees. What is employees' readiness? Anything new in the factory, employees are reluctant and very hesitant to adopt. This is basic psychology. So you have to analyze the employees' basic skills and ability to acquire new skills. And they always have a reservation that is anything not really needed or anything which is going likely to go against them. So they're always hesitant to adopt this. So you have to remember that employees are most adopted, most affected by the changes in technology in an organization because they feel it is affecting their work environment. Basically, they are not robots; they are human beings. They also got psychological feelings. So these must be respected and they must be taken into confidence and explained exactly what is required by them. And they can be trained and they can be accommodated appropriately in your factory to have a better process. Actually, if you can locate some employees which are willing for some promotions, then they will happily go on training and get themselves promoted in the organization and they can work better in the company if you take them into confidence exactly what you are going to do in your company. And this is the job of the human relations department, and some of them are doing it very successfully. What are the challenges? First is high economic cost to meet various technological needs. As I told you, we need equipments to be adopted to send data and receive data. So you may have to change the equipment itself, or you have to add on something to the equipment to make this facility available. This is going to cost little money. Then business model adaptation by changing organization structure. As I explained in the earlier slide, you have to change the organization structure so as to make it more effective to adopt Industry 4.0. Then the economic benefits are still unclear, but this can be predicted. Even the large investment, as Sanjay Shroff talked about the ROI. This ROI is not yet predictable 100%, but still you can take that calculated risk and find out what will be the ROI, return on investment, by doing this investment. Because unless you invest, you won't earn. So you have to invest something to earn much more. And surely this can be predicted with different models adopted. There are many social issues. Number one is a privacy issue because whatever you are going to do has to be transparent for Industry 4.0 in your own organization. So there could be some privacy issues. Some drawings which you are not sharing with others may have to be shared. Some data may have to be shared. But you have to trust your customers. You have to share your organization. You have to share your employees. This is a typical case will be you have one customer and many suppliers. Then suppliers may worry, or the customer may worry because the data will be shared with many and may be stolen, and your competitor can take that. But that risk you have to take. This possibility of surveillance and distrust is always going to be there, but you can always overcome that by some other means. There is a general reluctance by all stakeholders because anything new which is risky, the stakeholders may be little reluctant to put in more money. The IT department will be very worried because they will feel that they're reluctant or until they adopt to the new technology, they will not be able to deliver the goods. But I'm sure the IT department today are quite competent to understand the needs, and they can get trained and enhance their capability to meet these new challenges. They need not have the fear of losing the job or work. Then if there are more automatic processes and IT control processes, then the workers and the employees may feel they lose the job. Actually, automation does not make the jobs lose, but new jobs are also created elsewhere. But that has to be properly explained and trained for those different jobs so that it can be adopted in different places. I talked about that a few minutes back. So employees need different training so they can have different environment for working, different machines they can work. And this is bound to happen. Automation is going to come whether you like it or not. And this has to be thought very carefully. I say it is a social issue because whenever a job is lost, it affects the society. So that is why I'm calling it a social issue, and this must be tackled that way. Because as a manufacturer or a supplier, we're also doing social service to the society by employing people. So we are also a part of the society, and we are also helping them in enhancing their livelihood. So this has to be thought very carefully. There are political issues. I'm not setting political issues from that angle, but political means the government angle. There are no regulations or standards or certifications as on today, which can make all companies come together and standardize something or standardize some process and do this. This is very tricky. There is another standard CQI 27 about which we may be talking maybe in near future. The CQI 27 standard is similar to this, but there is a standardization in that. The same standardization we can adopt for this Industry 4.0. Maybe I request our President, Mr. Sanjay Shroff, and all associations here related to Indian Foundry Association or Indian Foundry Fraternity to join together and form our own standards, our own processes. Why not name them our own standard like other countries do and say that this is must be followed by all industries if you want to meet the certification for Industry 4.0. The certification is not a right word because Industry 4.0 is not a certificate. It is a method of working. But we can say this is a method of working one has to adopt. And there is no clarity of legal issues. Suppose the data is stolen or data security has some problem. The laws are not still clear. So this clarity has to be generated. But I think the association can do this by coming together and make some regulations possible. At least to begin with, we can make it start somewhere. What are the internal challenges? The IT security issues I talked, there are snacks and we have to be careful. Then machine to machine communication has to be very reliable. There should be no power shutdowns. It has to be 100% reliable or your process will stop. You have to need to maintain integrity of production processes. Integrity means integrity of the processes as far as machines are concerned, as well as human integrity. You have to avoid any IT snacks or which would cause production outrages because IT must not stop production at all. Presently, the banks had some IT snacks, the bank operation stops. If the IT snack is there, airline booking stops. That should not be permitted in the factory. But these have to be care of. There has to be a second plan B ready in case plan A fails. Then you have to protect your industry know-how. This is possible because this can be done by certain encryption of your data and taking help of IT experts. This is possible. You can use a digital key to encrypt this data. It can be shared only to companies. Then you need adequate skills to expedite the data from coming now to Industry 4.0. You cannot waste time. So you have to do it very fast. If you lose time, you lose money also because you already invested in going for Industry 4.0. And basically, the management from the top to low has a must have commitment. That is why I told a few minutes back that the employees must be taken into confidence and there has to be good communication from the top to bottom and commitment must be brought in from all. It should be explained in their own language, own focused communication, and told them clearly what are the benefits and how we should achieve it. And insufficient qualification employees, I already told you the training has to be done. So these are internal issues which has to be thought of very carefully. Now, with all this readiness, we can go for Industry 4.0. But again, I'm repeating, we have to understand the vast data and analytics, modern information and communication technologies like cyber physical system, vast data analytics, cloud computing is needed. This will help early detection of defects and production failures to enable their prevention and enable increased productivity and quality. So this is very, very important. For this, I am clarifying one example, which is an important slide because we talk about cyber security and all that. What is cyber? To understand cyber, yet one must understand the role of cyber. That means vast data and analytics. So let us understand it again. Cyber is related to characteristics, the culture of computers, information technology, virtual reality. So care from cyber threats must be taken. This itself would be another topic for discussion. But you take care of these cyber attacks. Don't get worried or don't get frightened because I'm saying so. But it is just like a fire. We take fire prevention measures. So similarly, if you're taking good care of cyber attacks, everything can work very finely. We can easily go for Industry 4.0. So we should give a thought again before deciding. Yes, the data can be stolen, but no human interference, no scope for errors will be there if you adopt this. And please find out if your equipment has those ports or capabilities. If not, then ask the supplier to add on or buy the equipment. I've talked about machines, spectrometers, milling machines. Any data collected by humans is not reliable. So you have to make it reliable. In a typical foundry, we still have to rely on human beings for collection of data. For example, additions in molten metals, for example, is still entered by human beings in many places because we cannot say it is 100% foolproof. There could be errors. For example, he weighs the additions to be made in a molten metal on the weighing machine, a weighing scale near the index of furnace, and he puts in the molten metal. But I don't know whether he really puts everything there or there is some spillage. So what goes into the metal and what is actually weighed, there could be some variation. Also, you have to check the competence of domain knowledge of training institutions, consulting agency. Don't jump into them. Please find out their competence first. Then allow them to train you because they also train from your mistakes. They train themselves from your experiences. Don't allow to do that because you're then allowing them to use your data for something else. This is not fair and this is against ethics. So find out good training institutes, good trainers. They can train you. There are good trainers available for Industry 4.0. And decide for Industry 4.0. So before going into final decision, I'm repeating, you take a final and needful consideration from cost, benefit, and ideas and needs, and ask yourself first whether you are at least in Industry 3.0. There is no point in jumping to Industry 4.0 if you are nowhere. One should remember that this is not a standard which is mandatory to be followed. Your customers may tell you to follow that, but it is not still so today. It is for your own sake. But it is just a good system to improve the process for more benefits. So finally, I will say, go for it. And I have my best wishes for everyone. So please grow and prosper. Thank you.